Bruijn's code. So the Bruijn's sequence is a binary. The Bruijn sequence of degree key is a length to k-circle binary string. So that's the definition, where every binary string of length k occurs exactly once. So what does this mean? So it means that let's imagine let's imagine at degree 1 the Bruijn sequence. So in degree 1 the Bruijn sequence, you would have 0 and 1, and in the sequence every bit would occur twice, and afterwards you would begin with 0, you would go back to 1, and you would go back to 0. So that degree 1 the Bruijn sequence. Right now the Bruijn sequence binary, the Bruijn sequence of degree 2, for example, you would every time you would actually substring length would be of 2. So it means that well, we would have 0 0 possibility, 0 1, 1 1, and 1 1 0 possibility, and we can have degree 3. So the Bruijn sequence we have 3 0 would be able to have 0 0 1, afterwards 0 1 0, 0 1 1, 1 1 1 0, and this kind of encoding. So this kind of encoding I'll show in the next slide. It's actually used to it's used already for different in different applications, for example, robotics, and actually was proposed by the researchers, I think, in the prospect to synchronize the quantum communication channel. And here you can see the graph that was actually I found in the paper, posted, I think, by Zhang, in which they describe how actually this kind of synchronization can be done. So the idea is that we have this 2-4 so binary divergent sequence of the length 4. So, and what we'll do here in red, we have the clock signals that would be super interleaved. So in between the clock signals, you would have this divergent signal. So one clock signal, one Bruijn, one clock, one Bruijn, one clock, one Bruijn, and you would actually synchronize your local system with this manner. So, for example, if you detect a photon in horizontal or vertical polarization, you would detect only photons that are within this specific clock. With that, you would keep on those photons that are within the specific clock width. So, and everything else you would discard as a random noise. And so that would be an idea to actually solve this synchronization problem. So currently we have a different quantum communication.
So Martin, yes? But yes. How is that timing synchronization channel sent? How is it? Because I mean, it's got to be sent to the ground somehow, or vice versa. Is it also an optical channel, or what?
So yes, so you have a beacon. So this kind of sequence would be superposed on the beacon, on different beacon that so you would have, for example, the quantum source with which you send the photons, and you would have another beacon upon which you actually superpose this synchronization information. And this beacon would contain this clock signal and interleave with the Bruijn sequence. And afterwards, because of the beacon frequency would be less than this frequency of the of the quantum channel, you would need to interpolate the data of the clock. So that's the main idea.